Good morning, everybody.
Morning, sir.
Good morning. So today we are going to be looking at trigonometry. All right. So I'm going to look at trigonometry. We're going to look at bearings, right? And we are also going to look at just a minute, right? Let me just see the topics here. Yeah, the cosine rule and the cos rule, all that is trigonometry. And we're also going to look at angles of elevation and depression, right? And then I will show you all some videos, some Kerwin Springer videos, because I've been telling you all to look at his videos. So I will integrate some of those videos into the class itself, right? With where he will be explaining how to do the past papers and, you know, if you all will be okay with that. Everybody cool? Class is going to be regular 3 hours, Sanjay. So let us get started with our class today. So trigonometry, what is trigonometry? It is a branch of mathematics that describes the relationship between the angles and the lengths of triangles. Now, trigonometry is used in fields such as navigation, it's used in architecture, surveying, engineering, and the manufacturing industry, as well as other fields, right? So some of the notations and some of the notes in here, I'm going to just leave it out because we did it when we did triangles, and we also did it when we looked at Pythagoras' theorem and stuff like that. So I won't be going through all of that because remember, it's just 3 hours and I'm trying to finish the syllabus. We have, I'm finishing, officially I'm supposed to finish by the 18th of May with the Monday class. So that week will be the last week that I'll be teaching, right? For all of my classes, because I know we have some people from the Saturday class as well as the Wednesday class sitting in right now. So that week, the week of the 18th, is the last week that I'll be teaching you all, okay? So right angle triangles, we already know what right angle triangles are when we did triangles and stuff like that, right? And of course, from our lesson on triangles, we know in a right angle triangle, the longest side is always opposite the largest angle. And the largest side of a triangle is called the hypotenuse, okay? Now, in a right angle triangle, if you are given an acute angle, as is the case here, as you all can see, theta over here, which is at the vertex A, opposite the side of the angle is facing, which is over here, A, it's always called the opposite. So again, the hypotenuse is always the largest side of a triangle, as you can see here, and it is always opposite the largest angle. So the largest angle is 90 degrees, and opposite the largest angle is the hypotenuse. And then in the question, if they give you an acute angle, as is the case here, opposite the acute angle is the opposite side, right? That's referred to as the opposite side. Now, if they give you the hypotenuse and they give you the opposite in a right angle triangle, you know that you're supposed to have a hypotenuse, the opposite, and the adjacent. So if we already have the hypotenuse and we already identify the opposite, then the remaining side will obviously be the adjacent. Any questions so far? You guys, any questions? Hello?
No,
Don't hear me? Okay,
no,
great.
sir.
So let's look at this triangle here. We are given the largest angle here, this 90-degree angle. Opposite the angle of 90 degrees is the hypotenuse. As you can see here, we have the angle here, the acute angle given here, and opposite this acute angle is the opposite. So since you know here's the hypotenuse and here's the opposite, the remaining side will be the adjacent. All right, if you all have any questions, please raise your hands and stop me and whatnot, right? Now, solving triangles. Before you can solve, as you know, a triangle has 6 elements, right? They have 3 sides and 3 angles. We did how many triangles and whatnot, right? So a triangle is specified by 3 particular elements, and we need to be given those elements to solve for the remaining elements. And the 3 elements that specify a triangle can be any of the following combinations. Sorry, the 3 elements that specify a triangle, it can be any of the following combinations. It can be 2 sides and the angle included by the side. It can be 2 angles and their common arm, or it can be 3 sides, or a right angle, a hypotenuse, and one side. Everybody cool?
Yes, sir.
Okay, can somebody remind me after class to send you all the handout for yesterday's class and all the other handouts? I forgot.
Yes, sir.
Yeah, just remind me after class, right? In the WhatsApp chat. So we looked at Pythagoras' theorem when we did triangles, so I will not be going into that. What I will be going into is the trigonometric ratios. Okay, so let me just turn on my camera so you all will be able to see the trigonometric ratios easily. Right, so there are three trigonometric ratios. Sine, but it's abbreviated as sin. We have cosine, which is cos, and we have tangent, which is tan. Okay? Now, an easy way to remember them is so, ka, toa. This is how I learned it when I was in school, right? This S stands for sine, C stands for cosine, and T stands for tan. Yeah? OH stands for opposite over hypotenuse. So in sine, we have opposite over hypotenuse, right? As you can see there. Then next we have AH. So adjacent over hypotenuse. So adjacent over hypotenuse. And next we have tan, which is opposite over adjacent. Any questions there?
No, sir.
Okay. Now, once you remember it's SOHCAHTOA TOA in terms of sine, cos, and tan, a lot of students, they told me that our way of remembering it is, oh heaven, another hour of arithmetic. However you want to remember it, feel free to remember it. I find the easiest one is SOHCAHTOA TOA. That's the method I learned, and I teach this method religiously because it's the easiest method to remember the the trig ratios. All right? Let's remember SOHCAHTOA TOA. Of course, you have to know how to spell it, right? You can't be memorizing SOHCAHTOA TOA and then you're spelling it wrong and mixing it up. Okay? SOHCAHTOA TOA. Sine, cosine, tan, opposite over adjacent, adjacent over hypotenuse, and opposite over adjacent here. Right? Again, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Everybody good? Make sure and take this down quickly. I'll give you all a minute to take it down. You're finished?
Yes, sir.
All right. Okay, I see somebody just messaged me and say 1 minute again. So, okay. right, so can we continue?
Yes, sir.
Sanjay, don't shout, please. It's really loud when you shout. And I have on headset. Okay, so let me go back to the handout now. Right, so as you all can see, of course, it's sine theta, cosine theta, tan theta, right? Theta meaning the angle. So it's sine, whatever angle they give you, and then it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, etc., right? I forgot to include the theta when I was giving you all the trig ratios. So let us look at this first example here. Calculate the value of y in the triangle shown. So what are we given here? Can you all see what we are given? Let me transfer this to our Microsoft Paint. Right, let's see. What are we given here? Anybody can tell me?
The adjacent and the hypotenuse.
The adjacent and the hypotenuse. We are given the adjacent, Emily?
Oh no, the opposite and the hypotenuse.
Oh, we are given the opposite.
No, you're given
the Oh wait, oh I just see why. We're not even given that.
Nope. Let's see what we are given here. You have to look what you to know which rule to use, which ratio to use. You have to look at what you are given and what you have to find. So you are given what? The hypotenuse, and you have to find what? What do you have to find?
Opposite.
No. This is the acute angle here. So that means here is the opposite. They didn't ask you to find the opposite.
the adjacent.
Right. So since they give you the hypotenuse, and we know for a fact that if this is the opposite here, then that means here is the adjacent, right? So since we are given since we are given the hypotenuse, and we also have to find the adjacent, which one of the rules, let me write it down. So, ka, toa. Which one of these cater for both the adjacent and the hypotenuse? Which one?
Tan.
Tan? You see in hypotenuse there? In tan?
Cos.
What's that?
Cos.
Cos. Yes, cos. Cos includes the hypotenuse and the adjacent. Remember, we are given the hypotenuse and we have to find the adjacent. Okay? So the only one that caters to that is cosine. So how do we do this? Remember, the formula is cos theta, and theta is whatever the angle is equal to adjacent over hypotenuse. Not so? So it's cos. And what is the angle? Anybody?
41.2.
Yes, 41.2 is equal to, anybody knows what is the adjacent? What is the adjacent? Y over hypotenuse, which is 8.2. Agreed? Agreed?
Yes, sir.
Right. So as you can see, we need to find for y. So we can't just so if we find it for y, what do we do?
So we carry across everything.
Right, carry across what?
8.2.
So we carry across the 8.2. And this is division, it goes across, it becomes multiplication. So cos 41.2 is multiplied by 8.2 is equal to y. So on your calculator, you will press show you how to use a calculator for this. On your calculator, everybody see it here? You have a cos button here, COS. Those of you who have calculators, you press cos 41.2 equals, when you get a long thing, you multiply it by 8.2 equals, and you will get 6.16. And of course, we approximated 2 decimal places, so it will be 6.17. All right? Yes.
Start over, please.
Cos 41.2 is equal to, and you get that, and you multiply it by 8.2. And you'll get 16.169, which is approximately 16.17, corrected
Okay,
to 2
I
decimal
get
places.
it.
All right? So let's go back here. So the answer is 16. So y is equal to 16 point, sorry, what was the answer again I told you all?
6.16. No, 6.17. 6.17, so
6.169, sir.
Yeah, 6.1,
17.
yeah, 6.169, which is approximately 6.17. And of course, if you approximate it, you have to put the 2 decimal places. Right? I'll give you all a minute to take it down, and then I'll give you all one to try for me. Okay, try this one for me. Okay, so anybody can tell me what we're using here?
Sine.
No, Musa, that's not the answer.
Sine, so we're using sine.
Why are we using sine?
Because it has opposite and hypotenuse.
Right? No, it doesn't have hypotenuse. We are asked to find hypotenuse. So yes, it has opposite, and we are asked to find hypotenuse. So ka, toa. So again, this is opposite, and we are asked to find, let's write that back. And we are asked, we are asked to find hypotenuse. So the one that caters for opposite and hypotenuse is sine. So we know we're using sine. Sine theta is equal to opposite over hypotenuse. So sine, what is theta, anybody? Anybody, what is sine? No, Musa, that's still incorrect. What is
Opposite over hypotenuse.
No, what is theta? I mean, what is theta?
The angle.
Which is?
24.
And theta, opposite here, as you can see, is opposite here. What is the opposite? 6.3 over the hypotenuse, which is x. Not so? Yeah? Now, as you all can see, the unknown is to the bottom. So we can't just take it and carry it across. Agreed? What we could do here to make things easier is to just put this over 1 as a fraction as well, and then do what? We can cross multiply. So sine multiplied by x will give us sine 24 multiplied by x. And of course, 6.3 by 1 is just 6.3. Yes? And then of course, we take across, we want to find x, right? So we take across sine 24. So x is equal to 6.3 all over sine 24. Any questions so far?
No, sir.
All right.
So you could do it over, please.
Sure. From this point here?
Yeah.
All right. So all I'm basically doing is making here a fraction too. So I just put over 1. Because as you can see, the unknown here is to the bottom. So we don't want to just take this and carry it across because we're running some complications there. If it was to the top, then we could have easily done that, right? So to get rid of this, you could cross multiply for the sake of simplicity. So sine by x, sine 24 by x will give us sine 24 multiplied by x. Because if I put the x together, it will look too confusing, right? So that's why I'll leave the multiplication. And we cross multiply here now. So 6.3 by 1 is just simply 6.3. Now we don't want sine 24 multiplied by x, we just want x. So sine 24 does not belong here. If I said 23, I apologize. So we just want x. So x remains here. X is equal to 6.3 all over sine 24. Okay? And if you take your calculator and you press 6.3 divided by, and you press sine and 24, you will get 15.49. That's just corrected to 2 decimal places. I hope you understand where it went wrong, Musa. Musa?
Yes, sir.
You see where it went wrong?
Yeah.
All right. So I'll give you all a minute and then I'll change it to give you all the next one to try. I will do this one for you all, then you all will do one for me, okay? Okay, I'm taking it off now. So I will do this one for you all, okay? So here we are asked to calculate the size of angle A to the nearest 0.1 degrees, so nearest 10th degrees, all right? So in other words, they're asking you to approximate your answer to 1 decimal place. If you have your knowledge on decimals, you will know that, yeah? So which rule are we using here? Let me just write down the cosine, not rule, the trig ratios. So it's so, ka, toa. What are we given here? You guys, what are we given?
Hypotenuse and opposite.
Yes, we're given the hypotenuse, which is 5.72, and we are also given the opposite. So which one caters for that?
Sin.
Correct. So remember it's sine, sorry, just a minute, sine theta, which is equal to opposite over adjacent. And in this case, theta is really A or alpha, right? So sine alpha is equal to opposite, which is 3.6 over the hypotenuse, which is 5.72. But what is the question asking us to find? And they're asking us to find A or alpha. Yeah? So,
Yes.
so all we simply do is take, because remember we don't want sine, we just want the alpha. So this doesn't belong here. We take it and we carry it across. Now just like when a positive goes across, it becomes a negative. Of course, you don't have like negative sign, right? So when it goes across, alpha remains, or A if you want to call it, is equal to, so when sine goes across, it becomes sine inverse. All right? Not to worry too much about that. And you multiply it by, of course, 3.6 all over 5.72. Now let me show you on your calculator how you're getting that. So you take your calculator, all right? And let's see now there.
Yeah.
Right. Now, as you can see, you have sine here, okay? But above sine, in small here, you could see sine to the power of -1. Let's see now there.
Yes, sir.
Right. So to get that, to get anything in orange, you have to press second function. If you have a Casio calculator, I'm sorry, I can't help you. I told you all from day one, I don't know how to use Casio. I know sharp. So you press second function, sine, and as you all can see on the top of the screen, sine inverse comes up. Try it, you're gonna like it. Try it on a calculator. Right? And of course, now that we know it's 3.6 over 5.7, so say open your bracket, 3.6 divided by 5.72, you close your bracket, and our answer is 39.00. And of course, they want us to put our answer to the nearest 0.1, which is the nearest tenth, which is this first decimal place here. So our answer will be 39.0. Everybody okay? Any questions?
No, sir.
So let's go back to the question now. So the answer for this will be 39.0, of course, degrees. Yeah, so let me give you all one to try now. Can I take it off? Well, I assume your silence is yes. Oh, I now see now this here.
Yeah.
And let's say I have a minute again.
Sir, your laptop freeze.
No,
It's stuck on our screen.
no, it isn't. I just didn't click that because somebody wanted to finish. Yeah. So try this one for me. I'll give you all 5 minutes for that. And I'll be calling on some people to answer, okay? Oh, sorry, I don't see the answers. Dion, yeah, you close, but you're off. Well, no, actually, no, you're correct. Emily, you're also correct. Macy, double check you're kind of correct, but you're kind of wrong too. You're close. You're very, 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 very close. So by now, you all should know. That's not, huh? No, Sanjay, you are off. No, that's also incorrect. So let's see what we have to work with here. We are given the opposite and the what? Adjacent, right? This is the adjacent because obviously we know here's the hypotenuse. Okay, so the one that deals with the opposite and the adjacent. Sorry, I don't know why it's writing like this. Is tan. So tan theta is equal to opposite over adjacent. All right. So tan alpha is equal to the opposite, which is 3.7 over the adjacent, which is 5.62. All right. Now we need to find what is alpha or A. So again, we need to carry tan across. So tan goes across. So we left with alpha or A is equal to tan inverse, because when tan goes across, it becomes tan inverse of 3.7 over 5.62. Okay? Now, you will take your calculator, you will press second function, tan, and of course, you'll get tan inverse come up. You open your bracket, 3.7 divided by 5.62, you close your bracket, you press equal sign, and you will get 33.359. And of course, you can approximate it to 33.4 because, just I'll show you why. The answer is 33.359, etc. And it's set to approximate it to the first 0.1, right? So that's right here. So as you can see, this 5 is 5 and more. So you add 1 to this 3 and it becomes 4. So therefore, our final answer will be 33.4 degrees. Any questions there? No, Sanjay, answer is still incorrect because you have to approximate to the first 0.1 degrees, to the nearest 0.1 degrees.
Sir, in questions like these, you have to find the inverse for all angles.
Like when I carry across tan?
Yeah.
Yeah, when you have to find the angle itself, because remember it's tan theta, right? And theta is whatever the angle is. And if you don't have a known angle, then you have to carry it across and it becomes the inverse.
Okay.
But as in the cases where we did before, we were given the angle itself. So it would have been tan, let's say 24 is equal to something over something. But in the case where you don't know the angle itself, you have to carry across the tan or the sine or the cosine and it becomes the inverse. That's provided that you don't know what the angle is. So let's move on then. Let me take this down. I don't understand what you mean by the correct sign, Rennie. What sign are you talking about? You have a mic you can turn on so I could probably talk to you. I don't understand what you're talking about. No, if you had chosen sine, which is SOH, right? You would not have gotten the same answer because sine requires you to know hypotenuse. And in this case, we do not know what is the hypotenuse. As you can see in the question, the hypotenuse is unknown to us. So we cannot use sine. The only one that you could use is tan. If you use any others, you will not get an answer and you will not get the same answer as well. So you have to look at what you are given and what you're required to find. Always. Always look at what you are given and what you're required to find, and that will help you to determine which one of the ratios to use. Okay? Hope I answered the question. No problem. All right, so let us move on from the ratios now. So now we're going to look at non-right angle triangles. This is the sine rule, right? Now I want to give you all some notes for this, right? Not from the handout. Actually, yeah, I'll give you it from the handout. So we have a triangle here. The sine rule is, actually no, let me write it down for you. This is the sine rule, right? So y'all will write it down for me. Write together with me so I can erase it after.
So for the second one, you said 2 sides on one side.
Oh God, sorry. 2 angles on one side. I was just checking to make sure you were paying attention, of course. Okay, take it down. Giving you a minute for that. Can I take it off now?
No, sir.
Not, just give me 1 more minute.
Okay. 60, 59, 58, 57, 56, 55, 54, 53, 52, 40, 45, 35, 30, 25, 10, 9, 8, 7, 6. Okay, I'll take it off now.
No, sir.
A minute. No, give me 2 minutes.
I was just joking. I'll leave it up for the rest of the 2 hours. Is that okay?
Yes.
Okay, I'm done. No, you can take
No,
it.
no, don't take it off. I saw it then.
Okay, Sanjay, don't scream. I have on a headset.
I'll lower down my mic for you.
No, you are screaming on the mic. That's why it's sounding so loud.
I'm like 2 feet from my mic.
All I finished now?
No.
Yes.
Jeez, on ages.
Sanjay, you could just get it from me.
Hold on, only last one.
I have a little animation to
Okay,
show
you
you
can
too, right?
change it.
So I will show you that in a little bit. That will explain angles of elevation and
I
angles of
finished.
depression. So let's do an example. If A is equal to 10 centimeters and angle A is equal to 60 degrees and B is equal to 5 centimeters, find angle B. Now, obviously, we know we could use, okay, so we given small a and we given angle A. So we given the side A, so that's A over sine A, And what are we also required to find?
B.
We are given small b, and we have to find angle B or sine B. So we know we're definitely using this ratio here. A sine A is equal to B sine B. Okay? Now, A is equal to 10. Sine is, of course, sine 60 is equal to 5 over sine B. We don't know what is sine B, so we write back sine B. Yes, people? So how do we make sine B the subject of the formula? Anybody can tell me this? If anybody can tell me what's the next step? I'll give Raleigh $1 million.
You cross multiply.
Cross multiply.
Okay, I was just kidding about the $1 million part. But yes, you cross multiply. Okay? I didn't think I would have figured it out, but yes. All again, smarter by the day. So 10 multiplied by sine B is equal to 5 multiplied by sine 60. Okay? Now we don't want this 10 here, so we carry it across. So we are left with sine B is equal to, we can work this out, or let's just put 5 by sine 60 by 10. So let's work it out. 5 multiplied by sine 60 is equal to that, and then multiply by
So
10.
it is supposed to be divide by 10?
Yeah, what are you doing?
Of course. I was just checking to make sure I was paying attention. You know, I like to do these things off and on. Very good, Cheyenne. Very good observation. Right? It's not that I make a mistake. Remember, as teachers don't make mistakes, right? Especially math teachers, we don't make mistakes at all. Right? Just making that very clear. People with iPhones make mistakes, but not people with Android phones.
Yeah.
So please.
Cheyenne is the one who had the iPhone, and she pointed out your mistake.
Shut up. I'm gonna put you in the waiting room, eh? Until you admit that that iPhones are crap.
That's okay.
Okay.
I don't need your class.
I'll put you in the waiting room one time.
I'll watch Cohen just like you tell me to do.
Sir, I'll give you $1 million if you put them in the waiting room.
I did though.
I was lying. I want the $1 million part.
So 5 multiplied by sine 60 is equal to, well, obviously you could put this long one if you want, and then or if you want you could just click divide by 10 one time and get the shorter answer. So sine B is equal to 0.43, so 2 decimal places, of course. Well, let me put 433. Yeah. And now we don't want sine B. What we want? We want B. Not so? So what are we doing? Anybody can tell me what are we doing?
You take a sign and put it on the next side.
And it becomes what?
Division.
No.
Inverse. Sine inverse. Hold on, inverse.
Yes. Sine inverse of 0.433. So on your calculator now, sine, of course, second function sine, 0.433, and we will get B is equal to 25.65, which is approximately 26 degrees. Or if you want to be more specific, if you want, 25.7, if you so desire. Yes? I'll leave it up to you all. I'll give you all a question to try now. Come on, we're not going to erase, right?
So is this the last Monday class?
No, I said that in the beginning of class. The last Monday class will be the 18th of May.
So is this a new term?
No, Sanjay. Can I take it off? Yeah, no. You guys, yes, no, take it off.
Yes, sir. Go ahead.
All right. So I'm going to give you all one to try for me. If A is equal to 8 centimeters, angle A is equal to 45 degrees, and angle C is equal to 70 degrees, find C, small c. So I'm going to ask either of the following to ask me to answer this question for me. So it's either going to be Howard, Joshua, or Miguel. One out of those three. I want the answer for this question, right? So you can privately message me on the chat here, and I will tell you. Okay?
So our internet just cut off.
Okay, no problem. I'll get entry now.
Yeah.
Okay, you all finished?
No, so we just joined back in. Our Wi-Fi just cut everybody off.
Oh, no, not all yet. How are they? How are you all finished?
No, yes, sir. Give me a minute.
All right, what about Miguel?
So I'm still working on it, so just now.
And who was the next one? All right, Joshua, you finished? So what is the first thing anybody can tell me? What are we doing? We had a setup. What are we given? A and angle A as well, right? So any one out of the three people, they could put on their mic and tell me what we're doing. Even
We
if you
will
didn't,
be replacing.
not you, Sanjay. Power. Joshua, you could type, I know your mic not working. And Miguel, or you could turn on their mic. And we'll do it together. It's okay if you get it wrong, that's fine.
Sir, it's asking to find C, sir.
Uh-huh. So what do we do first? Don't do that, right, man? Uh-huh. So let me help you with this part. A sine A is equal to what?
Adjacent.
Adjacent, where you get adjacent from? That's the sine rule. And that's trig ratios. We're not using trig ratios anymore. Something over something here. Something over sine something. What goes here? People, small c, big C. And now we substitute. A is 8 and sine 45 is equal to C. We wasn't given small c, we was given capital C, which is sine 70. Okay, at least you all should have up to date, I would assume.
Yeah.
All right. And now what do we do from here? Anyone out of the three of you, tell me what we're doing. Power?
I'm not included in any three of them, right?
No.
Oh gosh.
Power or Miguel or Joshua, what do I do from here? What's the next step? Cross multiply, correct, Joshua. You cross multiply, so we will get C multiplied by sine 45 is equal to 8 multiplied by sine 70. Okay, so we can work out 8 multiplied by sine 70. So on your calculator, you press 8 multiplied by sine 70, and we will get this particular answer. So we save the answer, right? Actually, wait, let me don't do that yet. Let me carry across sine 45. This goes across. C is equal to 8 multiplied by sine 70 all over sine 45. Now we can use the calculator to figure it out. So C is equal to 8 multiplied by sine 70 is equal to that. And we divide that entire thing by sine 45. And we will get 10. Oh, yeah, now seeing Joshua was asking if it's 10 point thing. Yes, Joshua, you are absolutely correct. So the answer will be 10.6. Joshua, your answer slightly off. I don't know how you get that. But yeah, The answer will be 10.6 approximated to 1 decimal place.
So sorry there, my phone battery was on one on the charger unplugged there.
I'm sure.
So I don't
So-
have anything to do.
So how you I can't use my phone right now, Joshua, because I'm using my phone to stream this video here. So you all who didn't get this correct, or let's see what went wrong. Okay, good, Rennie, very good. Can I take this off, or are you all writing it out? I'm taking it off, right? Now I hope when I do notes in this blackboard, it is whiteboard, you all are taking down the notes, right? Because you would not find the notes that I write on this. Once I write it on this whiteboard, you do not get it in a handout, right? So I hope you all just be taking it down. Now we're going to look at the cosine rule. Right, try right on this. I'm giving you all 2 minutes for this. It is possible that we could go a little over the 12, right?
No, it is
So,
not.
so just be a little mindful of that because I am trying to finish the syllabus, and I did tell you all that I would have gone a little extra half an hour every class, but I did not do that. So now that we're coming to the end, there's a possibility that I might go like 15 to 30 minutes over, right? But it definitely wouldn't be past 12:30. But I will give you a short break, like a 10 minutes break, but we need to finish this topic today, right? So I might go a little extra time. So please be mindful of that. Every class from now might go a little extra half an hour. And remember, the Sunday class is no longer in session. Yesterday was the last Sunday class, right? And I finished an entire topic class yesterday. So that was that. Tell me as soon as I can erase, right?
You can
Yeah, you
erase.
can erase.
That goes for everybody. Everybody else.
Also, wait.
All right.
Okay, so go ahead.
All right. So example, if angle A is equal to 60 degrees, B is equal to 10 centimeters, and C is equal to 12 centimeters, find A. Of course, we know the formula is A squared is equal to B squared plus C squared. All right. Now, of course, minus 2BC cos A. Now, of course, you are given this formula in the exam, I believe, right? But based on this formula, you will, depending on what you are asked to find, in this case, we are asked to find A. Suppose we were asked to find B now, you have to know how to manipulate this formula to get the other two formulas. So since we know it's A squared is equal to B squared plus C squared, because I forgot to explain it just now and I erased it, so sorry about that, I will explain it here. So if it's A squared, then you know it's cos A. So A squared cos A. Then what remains is B squared plus C squared, so it's minus 2, and if this is BC, it's BC. So what remains here is B squared now. Let's check B squared and of course C squared, right? We know A squared is equal to B squared plus C squared. So if this is A squared, then B squared and C squared will follow a similar pattern. So if we're talking about B squared, what remains is what? And A squared plus C squared. Agreed? Yes, no?
We agree.
Right. So if this is C squared, what is C squared? And A squared plus B squared.
Yes, sir.
And if this is A and this is cos A, if this is B and here will be cos B. And then this is C, and here will be cos C,
Yes.
right? And since here was BC and we have minus 2BC, if here is AC, and it's just minus 2AC, and if here is AB, and it's just minus 2AB,
Yes, sir.
right? So if you were asked to find A, we're using this one. If you were asked to find B, you're using this one. If you were asked to find C, you're using this one, okay? And this is how you derive the formulas. I forgot to explain it when I gave you all the notes. So let's just use this one because we are only required to find A. Now, we know A squared is equal to B squared, and B squared is 10. So it's 10 squared plus C squared, which is 12. So 12 squared minus 2 into B, which is 10, into C, which is 12, cos A, which is 60. Okay? So A squared is equal to 10 squared, which is 100. 12 squared, which is what? 144. Minus 2 by 10 is 20. And of course, 20 by 12 is? Anybody? So that's 20 by 12, that's 240. And of course, cos 60 is what? In your calculator, you press cos 60, you will get 0.5. Yeah? So A squared is equal to 100 plus 144, which will give us 244, minus 240 by 0.5 is how much? That's like saying 240 by a half, which is 120. So A squared is equal to 244, take away 120, which is 124. And of course, we need to find A. We don't want A squared, we want A. So to get A, we have to find the square root to cancel off with this square. What you do on one side, you have to do on the other side. So this cancels with this, you're left with A. And of course, the square root of 124 is 11.14 to 2 decimal places. Do you all have any questions?
No, sir.
Okay. I'll leave it up for a minute. I'm taking it off now, right?
No.
Wait, please.
Okay, so you can take it off now.
All right. Let me do another example for you all. if A is equal to 15 centimeters, B is equal to 16 centimeters, and angle C is equal to 130 degrees, find C. So obviously, we know the formula is C squared is equal to A squared plus B squared. And if this is C squared, then we know here you have to have cos C and then minus 2 and whatever this is, AB. Agreed? So C squared is equal to A squared, which is 15 squared, plus B squared, which is 16 squared, minus 2 into A, which is 16, into B, which is, oh, A is 15, sorry. And this is 16, cos C, which is, of course, 130. So C squared is equal to 15 squared, and of course, you will use a calculator. 15 squared is equal to 225, plus 16 squared, which is equal to 256, minus 2 into 15 into 16 is 480, and cos 130 is negative 0.64. We'll approximate that to 2 decimal places, right? So C squared is equal to 225 plus 256, which is equal to 481 minus 480, of course, minus 0.64. So 481 minus 480. Oh wait, hold up. It's multiplied by this, not minus. Right, so my apologies. So 480, negative 480. When you calculate, you'll press negative 480 multiplied by negative 0.64, which will give us 307.2. Right, and of course we're adding because a negative and a negative is a positive, so that's why I got that there. So 481 plus 307.2 will give us 788.2, and we need to get rid of this square. So to do that, we have to find the square root. What you do on one side, you have to do on the other side. That will cancel with this. You're left with C, and the square root of this is equal to 28.1 centimeters, of course, approximated to 1 decimal place. Any questions there so far? People? I will unmute all of you, you know. Any questions?
Do we have a break now?
You'll get a break shortly, Sanjay, not now. I'll give you a short break before I start angles of elevation and depression.
So now you had to mute back everybody because like nobody mute themselves back.
That way I'll see how many people are actually here. So if you are here, unmute yourself. Sorry, mute yourself. So let me see what people are catch. Marcel, not here. Bala is not here. Sorrenta, Giovanni, Mamadou, Jeremiah Simmons. Oh, okay. I'm now seeing Marcel. Okay, Simon, so just you can just say it you're there. Simon, see what get on so. Jeez.
So what are you doing?
What? I'll press it until you unmute yourself.
Maybe let's have
Can I erase this now?
Yeah, so long time.
Okay. Let me give you a small note. When all three sides are given, with no angles, we use I'll give you a hint.
Pythagoras theorem.
No.
Pythagorean theorem.
No. So for example, we know a squared is equal to b squared plus c squared minus 2bc cos a, right? So we make this the subject of the formula more or less. Carry it across, you'll get 2bc, positive 2bc cos a is equal to b squared. And of course, you take this and you carry it across, right? B squared plus c squared minus a squared. And of course, you don't want this here, you just want cos. So you carry it across, so you get cos a is equal to b squared plus c squared minus a squared all over 2bc. Of course, if you were, of course, you know, you will have to manipulate the formula depending on what you are given. So it might be b squared and cos b, so you might have to manipulate the formula to get cos b or cos c, etc. Right? I'm just doing one for you, I'm not doing all. Okay, but the rest will follow the same pattern. And I'll do an example just to show you all what I mean by that. And then I'll give you all a short 5 minutes break, right?
So
I
you
mean,
said 10.
yeah, but I mean, I really want to finish and I don't want to go too late as well. So, I mean, you're at home, right? You could take your devices and walk around the house with it. 5 minutes is enough time to go use the washroom, grab something to eat and come and sit down by your device and eat while you're in class. It's not like all the well,
So
Sanjay and
I
Emily
left off
answering.
my computer.
Only Sanjay and Emily is answering, so it's not like everybody else is answering. So it's not like you all will have to put on your food to talk, you know? So you could eat while class is going on.
Me and Sanjay carrying this whole class through.
Can I erase?
Yes, sir.
Okay. Let me just do a quick example for you all. So for example, if A is equal to 14 centimeters, B is equal to 16 centimeters, and C is equal to 20 centimeters, find angle A. Of course, we know the formula is cos A is equal to B squared plus C squared minus A squared. You're not given this one in the formula sheet, right? So you have to know how to do this one yourself. All over 2BC. So cos A is equal to 16 squared plus 20 squared minus 14 squared all over 2 into B, which is 16, into C, which is 20. So cos A is equal to 16 squared, which is what? Anybody? 256 plus 20 squared, which is 400, minus 14 squared, which is 196, all over 2 by 16 by 20, that's 640. So cos A is equal to 256 plus 400, which is equal to 656 minus 196, all over 640. So 656 take away 196 is equal to 460 all over 640, which is 0.72. Yeah? Yes, folks?
Yes, sir.
But do we want cos A? We don't, right? So we just want A. So you're taking cos and you're carrying it across. A is equal to, if cos goes across, becomes cos inverse of 0.72. And on the calculator, you press second function, cos 0.72. This will give us A to be 43.9. And of course, we can approximate it to 44 degrees, more or less. Or if you want to be difficult and write 43.9 degrees to 1 decimal place, that's also correct. Yes? I'm giving you all a minute. Take a picture or something so we can erase it, so we can. Or they actually take 5 minutes break. We start back at 11:50. Sorry, at 10:55. It's now 10:50. I'm going to pause the recording. Somebody just remind me to resume the recording, please. Recording. All right, so I'm going to show you all a video and I'm going to do a voiceover of it, right? We're going to be looking at angles of elevation and angles of depression. Now, the best way to understand angles of elevation and angles of depression is to use a visual, all right? Because in the Saturday class, when I taught it, I did it from the handout, and I found that the students were not grasping the concept properly. So what I did was I got a video, and I'm going to explain the video, and I hope that the video helps, right? So when I'm explaining, if you have any questions, please write it down. Don't ask me during the video, right? It's a 13-minute video. I'm going to explain while the video is in session. And actually, I wonder if you also get the sound from it. Actually, no, I don't think so. So yeah, if you all have any questions, just let me know, right? Tell me if you all are hearing the audio from the video itself.
on applications of trigonometry. Now we're going to have a couple different videos on this section. In this one, the goal is that you will solve problems involving angles of elevation and angles of depression. And I'm going to explain what those two things mean to you right now.
You all hearing anything?
Yeah, we hearing.
Okay, great, great. So that way I don't have to do a voiceover. Unless you're all hearing, right?
Yes, sir.
Okay, great. So this is going to explain angles of elevation and angles of depression for you in a way that I will not be able to because I don't know how to do the drawing and stuff, right? So just listen and I'll explain after if you'll have any questions, all right? Everybody cool?
Yes, sir.
Okay, so I'm going to press play. It will explain angles of elevation and angles of depression for you.
All right, so I've got a hill right here, and let's suppose that you're the person at the top of the hill, and you got a friend at the bottom of the hill, and so you're looking down at your friend. Well, the angle with which you look down in order to see your friend, whether that's 20 degrees, 30 degrees, or whatever, would be called an angle of depression because it is going down. And the angle with which your friend would look back up at you with would be called an angle of elevation. But I've described those things to you. I need to show you exactly how you show an angle of elevation or an angle of depression. Anytime you're referring to an angle of elevation or an angle of depression, those angles are always in relation to a horizontal line called a horizon sometimes. And so to show you the angle of depression that you would look down at your friend with, what I had to do is go to your eye level and I have to draw a horizontal line first. And then what I'll do is I'll draw a line that goes directly from you to your friend, like so. And the angle of depression then is the angle between your line of sight to your friend right here and that horizon line right there. And very similarly, if I want to show you the angle of elevation with which your friend would be looking at you, well, you have to have a horizontal line in order to determine what that angle of elevation is. So from your friend's eye level, I would draw a horizon line as well. And then the angle between his line of sight or her line of sight and that horizontal line would be the angle of elevation. Hope that makes sense to you. Now, one more quick fact. If you remember back to your geometry days, the relationships formed by parallel lines and angles that they form with transversals, the angle of depression and the angle of elevation between you and your friend happen to be alternate interior angles of parallel lines, and so they're always going to be congruent to one another. All right, just an easy fact that you should remember. Let's go ahead and look at some problems then involving angles of elevation and angles of depression, and these are going to involve right triangles as well because we're still working with right triangle trigonometry. Problem here says that an observer standing on top of a vertical cliff spots a house in the adjacent valley at an angle. The cliff is 60 meters tall. How far is the house from the base of the cliff? First key to all the problems that we're going to be doing in section 11.2 is that if a picture is not given to you, you must draw a picture in order to be able to determine where the right triangles are that you can use to answer the question. And so we're going to draw a picture of an observer standing on the top of a vertical cliff, looking down at this house that's in a valley. All right, so maybe this is the cliff right here. Just really a line is all that you would need, but let's say here's the cliff, the edge of it anyway, and there's you standing on top of it, or some person anyway, the observer. And then this would be the valley down here. And somewhere along the valley, there's a house with a bit of a crooked side. That's unfortunate for that house. Okay, so the observer spots that house at an angle of depression of 12 degrees. So we need to draw an angle of depression like what I just showed you a moment ago. And remember to draw the angle of depression, then we've got to have the horizontal line. Now, I added the little stick person there, but truly for this one, we're going to assume the horizontal line comes from the top of the cliff because we know how high that is, and we don't know how high the person's eye line is, so we're going to be a little bit off. It's not going to be an exact measurement, but there's our horizontal line, and then we're going to draw the line of sight between the top of the cliff and the house. I'll just draw it to the middle of the house right there. All right, and so the angle that those two lines form is your angle of depression, and that was 12 degrees. All right, now we're also told that the cliff is 60 meters tall, so I'll label that there. And we're trying to figure out how far is the house from the base of the cliff. So essentially we're trying to find this distance right here. And again, I'll measure to the middle of the house. Can you see the right triangle that we're going to be using in order to find that measurement? Excellent. Now, of course, a vertical line has to be perpendicular to the ground. So this is going to be a right angle. And you see the 12-degree angle of depression that we had is not actually inside of the triangle, but this would also be a right angle here, and so you could subtract 12 from 90 and get that this angle inside the triangle is 78 degrees, couldn't you? Or you could use what I told you about the alternate interior angles, and you could say that this is a 12-degree angle right there. At any rate, we've got this distance to find, and we can use the right triangle that you see to find it if we just use a trig ratio. And let's say we use the 12-degree angle as our reference point. Well, we know the length of the opposite leg, and we're trying to find the length of the adjacent leg, so we would be using tangent ratio in order to find that value. All right, tangent of 12 degrees would equal 60 over x. Do a little bit of algebra, and you'll get that x is equal to 60 divided by the tangent of 12. And then use your calculators, approximate that value to 3 significant figures. That will tell you how far the house is from the base of the cliff. And that's about 282, let's see, meters. Those were the units that we were working with there. All right, fairly simple, right? This would be a more complicated example right here. We're going to end up using a couple different right triangles. It says that buildings A and B are across the street from one another, 35 meters apart. From a point on the roof of building A, the angle of elevation of the top of building B is 24 degrees. And the angle of depression of the base of building B is 34 degrees. How tall is each building? All right, well, again, we need to start with a picture here. Now I'm going to go ahead and put the ground first, and then the buildings will go on top of this. There's not a lot of information we have about the heights of the buildings because we're trying to find the heights of the buildings, but a context clue here for us as far as which building is taller is the fact that from building A, you can look up to see the top of building B because there's an angle of elevation there. So we're going to make building A the shorter of the two buildings. So that could be A, and here's B. All right, now from the top of building A, right there, if we were to draw the line of sight up to the top of building B, there's an angle of elevation there of 24 degrees. Now, we also have to draw the horizontal line from the top of building A so that we know where that 24-degree angle is. And, well, there it is. All right, we're also told that the angle of depression of the base of that building B from building A is 34 degrees. Now, I've already got the horizontal line from the top of building A, and so I just need to draw the angle of depression right below that. There. And a 34-degree angle will be here. All right, now we are also given one other fact, and that is that the buildings are 35 meters apart. And so the horizontal distance, there's a couple of places we could label this actually, but the horizontal distance from A to B down there, we'll go ahead and label that as a 35-meter distance. All right, now I've copied that picture onto a new screen, so I've got room to show you the work to go along with this. Since we're trying to find the heights of the two buildings, it would be nice to have labeled on the diagram where those distances are that we're trying to find, and let's just call the height of building A lowercase a, and then the height of building B can be lowercase b. And how are we going to find either of those distances? Well, you might already have an idea for the height of building A, because you can see this right triangle from the top of building A to the bottom of building A over to the base of building B and back. Let me highlight that triangle that we're going to use, this one right here. Okay, and you can see the right angle and all that, where that's going to go. Well, we don't know either of the acute angle measures for that triangle yet, but if we use the angle of depression from A to B and the fact that this is a right angle right there, we can figure out that this angle is going to be 56 degrees. All right, now the height A that we're looking for happens to be the adjacent leg to that particular angle, and we're given the opposite leg. We're going to be, again, using a tangent ratio here. We say that the tangent of 56 degrees is equal to 35 over A, and then you solve for A, you end up with about 23.6 meters as the height of that building. Okay, now
anybody can tell me how we got 23.6? If you do algebra, obviously it's 35 over A. So we want to find out what is A. So we can cross multiply there, right? So it will be tan 56 over 1 is equal to 35 over A, right? And then of course, you're supposed to know now, because we did enough practice, how he would have gotten 23.6 meters, right? So I'm just going to click continue.
to find the height of building B, if we're looking to use just a single triangle for that, we're a little bit out of luck because, well, this one triangle from the top of building B to the bottom and then over to the top of building A is not a right triangle, is it? However, we can use a pair of right triangles that I'm going to highlight for you in order to find the height of building B. And one of them we actually already know sufficient measurements for. Look at this. This triangle along with this right triangle. Okay, now we just got done figuring out the value of A, the height of building A, and if you look at the part of building B below that horizon line that we drew right here, well, that's just equal to A, isn't it? From here to there is that distance A. So we already know part of the height. What we need to do is then figure out how far above building A building B reaches. And so let's just call that a distance C. And we can use this right triangle at the top in order to figure out what that distance C is equal to. Now, right now, it looks like we only have one of the acute angle measures and no other measurements. Well, obviously the right angle. But the distance between the buildings is 35 meters all the way across. And so we know that this would be a 35 meter distance right there. And so C, yeah, I guess we're using a trig equation, right? Could be found by using a tangent ratio again. From the 24-degree angle, C is the opposite leg, you know the adjacent leg. So the tangent of 24 degrees equals C over 35. So that means C would equal 35 times the tangent of 24 degrees. And that gives you about 15.6. All right, and then we can say that the distance B is equal to distance A plus C. And they'll add the 23.6 with the 15.6, you get 39.2. All right, so A is 23.6 meters tall, B is 39.2 meters tall. That's how you find, or that's how you work with trig problems involving angles of elevation and angles of depression. Thanks for watching, guys. See you later.
Okay, so let's go back to the handout. So those examples, just a minute. It's quite simple to do the angles of elevation and depression, right? There's nothing too difficult there. Once you understand the trig ratios and you understand whether you are doing an angle of elevation and an angle of depression and you identify your triangles, etc., you will easily figure it out. Okay? It just takes a lot of practice, and practice will make improvement, right? So let's start bearings. Okay? So let me go to this whiteboard. You're hearing me properly, right?
Yes, sir.
Okay, great. So you all can hear the bearings. I'm giving you all 5 points to remember, right? Now, 5 points to remember when doing bearings. The first one, draw a sketch. This will give you a roadmap into the question, and you'll be able to see which rule you are going to use. And sometimes, even if they ask you to draw a diagram, still draw a sketch. Even though there's a diagram, draw a sketch and then draw the diagram. Right? The sketch will help you to visualize how the sketch is. The sketch will help you to determine how the diagram will actually be. Right? So please write on these. Next one. Draw knots on all the points, every single key point, whether it's a ship, a lighthouse, etc. Draw knots on the point, and then the bearing goes in a clockwise direction from the knot, right? You only do other cardinal points if they ask for it, right? Number 3, corresponding angles. And alternate angles. These are going to save your life. So make sure you understand these before you understand the other parts of trigonometry. These are very important, right? This will more or less help you crack the code in the question, right? Number 4, sine rule and cosine rule. You can either get one or both. Most of the time, you get both in these questions, right? Sine rule is like the final frontier for you in maths and tricks, right? At this level. So make sure you understand. You don't need to memorize the formula, but you should be very acquainted with it and questions involving these types of problems, right? So when you see it, you should know how to use your sine rule and your cosine rule, etc. Now, the formula is given in the formula sheet at the start of the paper, but make sure you do questions involving these to understand it, right? And number 5, make sure your calculator is in degrees. If your calculator is radians, you're going to get the wrong answer. Sine of something in radius is different from a sine of an angle in degrees is different. So make sure you see DEG at the top of your calculator, because calculators have a tendency to change themselves into radian, and gradients, etc. So make sure before you attempt any question, your calculator is in degrees, please, right? Because as I said before, if you have your calculator in radius and you have your calculator in degrees, then you are definitely going to get two different answers, right? And I have some people here in the class that can testify to that. Who was in the Saturday class? Let me see. Brianna, can you remember when I think it was Alicia, had her calculator in, no, it was Jada. Jada had her calculator in radians, and she's telling me she wasn't getting the same answer as I. And I told her it's because, right, you see? So that is very important when you're doing bearings. You make sure your calculator is in degrees. If your calculator is saying radius on the top, if you want to know how to change it, all you are doing, I could talk for a sharp calculator, I don't know for Casio. As you all can see this button here, it says DRG. So as you can see to the top here, my calculator is in degrees. I'm not sure if you all can see it properly, but if I press it, it goes into radians, as you can see here. And if I press it again, it writes GRAD, which is gradient. Your calculator should be in degrees at all times, unless you're using certain aspects of mathematics where you're required to change your calculator to radians to get the correct answer, right? But not to worry about that. So make sure your calculator is always in degrees to get the correct answer when you're doing a question on bearings, or in general. In general, your calculator should always be in degrees, right? So these are the 5 steps or the 5 points to remember when doing bearings. Any questions so far? Can I take it off?
Yes, sir. Go ahead.
All right. So let's go back to the handout now. Right. So in our study of trigonometry so far, we have been calculating unknown distances in triangles. We were given certain elements of a triangle, and we used their trigonometric ratios or sine and cosine rule to solve for any of these, to solve for any of the elements of the triangle, right? Oh, sorry, I forgot to share this with you all. Right? So bearings and the cardinal points. So bearings, the bearings utilize the 4 cardinal points. The 4 cardinal points, of course, are east, west, north, and south, right? But the main one when we use in bearings is north. Of course, between north and east, we have northeast, as you can see in green here. Between east and south, we have southeast. Between south and west, we have southwest. And between north and west, we have northwest. Okay? So let's look at this. Using the cardinal points, we can also describe the position of points that do not fall on exactly on any of these 8 points. To describe the position of point P and R from the origin, we follow the conventions shown below. So let's say we are given this diagram here, and P is over here. We're looking at the direction from north to P. In this case, it's 20 degrees. All right? So since P lies closer to north, which is N, than east, which is E, the angle measured from the north is 20 degrees. Therefore, the direction of P is N 20 degrees east, right? You start with N, so N 20 degrees east, meaning that it's going towards the eastern side. Similarly, the point R to E than north, the point R is closer to east than it is to north. The angle measured from north is 20 degrees, right? So that's from R to E, it's measuring from north. So it's from here to east. So therefore, to read this, we will see the direction of R is E 20 degrees north, okay? Here was from north to east, and here's from east to north, which is the reason for the wording here. Any questions so far?
No, sir.
Okay, great. Now, I will direct you all to some videos. I'm going to show you all some videos that explain bearings shortly. And it's a Cohen Springer video as well. I told you I believe in this man. He's really good, right? And I use his notes when I use his, some of his explanations, etc. when I am preparing my own personal notes as well, right? Because I did tell you all, as a teacher, I learn from others. right? I don't feel I know it all, and I accept criticism, etc. As you all know that for sure. When you all show me different methods in class, if I like it, I utilize it, etc. Right? And Kerwin Springer has some really nice videos on bearings, and I want to share it with you all because obviously he used some graphics and stuff to explain it, which I do not have on my laptop, and I do not know how to utilize. I only have a whiteboard on a laptop, and I utilize Microsoft Paint, and that is very difficult to use in itself. So I will show you all some videos, and I will explain through the videos. In fact, I don't even have to explain because he is doing some past papers, etc., and he will explain while we go along, right? So I urge you all to pay attention to it, and we will actually be doing the past papers through Kerwin Springer, right? It's not a matter of me being lazy. It's just he is explaining it in great detail, and he's using the graphics and writing on the screen that usually gives me a lot of trouble, right? So please forgive me for that. But you all know if it was under different circumstances in the actual classroom itself, I would have certainly explained it to the best of my ability, right? I always try to explain things for you all in the best of my ability, but in a case like this, I am constrained to a laptop and using the technology which I'm not quite familiar with, all right? So bearings. A bearing is a direction measured from north, which is what I told you in the 5 points, right? It's drawn from north, so it's measured from north in a clockwise direction, right? That was the second point in the 5 points I gave you all, okay? So again, a bearing is a direction measured from north in a clockwise direction and is given only by an angle. Bearings must always be written using 3 digits. So for anything less than 100 degrees, we place a 0 or zeros in front of the number to ensure that there are 3 digits. So for example, north on a bearing will be 0, 0, 0 degrees. Northeast on a bearing will be 0, 45 degrees. So you don't just write 45 degrees, or you don't just write 20 degrees. You write 0, 20 degrees or 0, 45 degrees. Everybody cool?
Yes, sir.
Any questions so far before I show you all a video?
No.
All right. So let me switch to the video. Just now I'm seeing somebody messaging. Just a minute. Emily, shut up. Apple product, my foot. So just let me know if you all are hearing the audio, right? Just a minute. Stop share. New share. Kerwin Springer. You all are hearing the audio, right?
All right, JK and L has some C ports here. 3 C ports. Start at J, went to K.
You all hearing the audio?
Yes, sir.
Okay, great. So this is an example of a bearings question that he's actually going to do. So please pay attention to it. And this is an actual past paper question, right? So it's 2 minutes long. So please let's pay attention and we'll go through it, okay? He broke it up into different parts, and I will be showing you all the different parts of the video, all right? So pay attention.
All right, JK and L has some C ports here. 3 C ports. Start at J, went to K, went to L, come back to K. Bearing of K from J is 54 degrees, and L is due east of K. We have the distance JK is 122, and the distance of KL is 60 kilometers. So we have to create a little bearing diagram for that. All right. So this video will just go and show you how to take that data, the data we have, and create this nice little bearing diagrams for that, right? So first thing I'm gonna do is draw the point, and always draw your north going up there, right? And including your...
Okay, I just want to just pay small attention, especially Emily there. As you can
point.
see in the back, it's Windows 7, right? No Apple products there. Just saying.
So he writes it on an iPad. Just listen, you know.
Oh, whatever. Okay, I'm gonna play video now, so be quiet.
G. Next up, we're gonna put the bearing because we aiming at point K now, and that's a bearing of 54 degrees. So 54 degrees is our good friend point K, and it's at 122 kilometers. So we could put in our point K there. All right. Next up, we have point L, which is to the east. So you expect to draw a straight line going to the east after putting your north. So that's going towards L there. Put in the point, and that's 60 kilometers in the distance. All right. So it's all about the bearings, making sure you have your North Pole, making sure your bearings are going clockwise from your North Pole. Right? Don't go the next direction. Go clockwise and put in your correct distances. Put in your point L. And the question asks us to show the north-south direction, show the bearing, show the distance. Alright, we show everything else except the south. So they requested for the south, well, let me give them the south. South is at the going downwards, right, on your paper. So south, 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 bam, 3 marks. Converted our bearing data into a bearing diagram.
Right, so that wasn't too difficult, right?
All right, so last time we had this diagram, and now.
Right, that wasn't difficult, right? Was it?
Nope.
All right, so let's look at another one. He's explaining the same diagram. This is part 2 now. That was part 1 to the question. It's taken from the January 2011 paper. It's question 10, part B. That was part 1. Let's look at part 2 now.
What do you want us to find? What do you want us to find? The measure of angle JKL, that's that angle. The distance JL, that's that line there, and then the bearing of G from L, so that's this here. All right, so straightforward stuff there. Well, actually, probably not so straightforward. Let's see what's going on. So the first thing is JKL. So to find JKL, what am I going to do? This angle here, let's see if you can see this. This angle here, which I'm shading off in blue, is equal to this angle here because of alternate angles. Yeah, man. So.
And remember, I told you alternate angles and corresponding angles will be your best friend when doing a bearings question, right? That was number 3 on the list.
Them equal. So, and you know this is 90 because this is going east. So yes, that's 90. So this is going to be 90 plus 54. All right, so angle JKL, we got that already. It's just a matter of writing it down. Angle JKL is 90 degrees plus 54 degrees. That's going to give me 144 degrees. All right, and you can write in a little alternate angles are equal there, just to cover your bases. All right, so JKL is pretty straightforward. The rest, sensing a cosine rule and a sine rule coming in. So let's see how that will be done. So the cosine rule is c squared is equal to a squared plus b squared minus 2ab cos c. I substituted in some values here, substituted some values. Let's see where they came from. Before I do that, I want you to consider this. If I have a triangle like this, hey, go back there. If I have a triangle like this, ABC, this is where the cosine rule starts. If you see a setup like this, you have a line here, and an angle in between. You should already start smelling the cosine rule from a mile away. Using that setup, I can find the value of this line here. Now, can you see that playing off in our diagram? Let me just skip to where this diagram can be shown. Let's see. Remember what I said, 2 lines, an angle in between, and we're going to get that line. So we have 2 lines.
And of course, I gave you all that when I was writing on the whiteboard. I gave you all that to write down, right? The conditions when you use the cosine rule and the sine rule. Okay, so you'll have everything from me. It's just to apply it to the questions, which is what he is doing right now.
I can call this line A, this line B, which is 122 and 60 respectively. 122, 60. And that allow me to find C, which is JL. And the angle in between is right here, which I just found. I found that to be 144. So that's where those substituted terms come from. So now I can go on and say, I can go on and work out that 122 squared plus 60 squared minus 2 by 122 by 60 by the cos of 144. Put that in your calculator. Remember, the best thing to do may be to put this in your calculator. First, work out that. Work out these 2 terms and subtract them both, right? Alright. Alright, so I can just erase this now. Make some room for my working. And erasing and erasing and erasing. So I can just finish off this question now. JL is equal to the square root of 3028, 174.1449, approximately that three significant figures. All right, let's look at the third part before our time is up. We want to find the bearing now. So I think it will be best for me to just bring back the diagram. There. So we want to find this bearing that I'm highlighting in yellow. And the best way to go about finding that bearing is by finding this angle in between, which I'll call theta, and just subtracting that angle from 270 degrees, because this whole thing here is 270 degrees. So if I find theta and subtract it from 270, I'd be able to find the angle. I hope you notice that he's always drawing from north, right? When you are doing a bearings question, you always take into consideration where the north is, and you always take into consideration from the north to the line or to the point in which you are considering, okay? You can understand that there. Take a little look at it. So I'm going to find theta first. Theta is really KLG, right? And here's what I have to use. I have to use the sine rule. The sine rule is basically a rule with ratios. So if I have this side and this angle, this side, and no, not that side, not that 60. The side we just found, I forget what the value was. This side and that angle here, we can therefore use the sine rule. The sine rule is a ratio of the side to the angle opposite, right? So A to capital A, which is this angle here, and B to capital B. So just substituting in those values, 122 over sine of theta is equal to 174.149, which is the value we just got for the line, over sine of 144. So I hope you can get that there. I'll just invert the two. I'll invert the two fractions because I want to get theta, so I'll swap them on both sides there, so I can get theta on top. Then it's just a matter of algebra, arithmetic, bringing across the 122. So it'll tend to multiply, and therefore theta is equal to the sine inverse of all that stuff, which is 24.31. Don't stop. Basically, when he reached this point here, are you all seeing where I have the cursor? All he did was take this this 122, this is division taking place here, and when he carried it across, it became multiplication, as you can see here, right? So all he did was take across this negative, I keep saying negative, all he did was take across this 122, and it became multiplication, because when division goes across the equal sign, it becomes multiplication. So that's how I got multiplication here. Now remember also, we just wanted theta, we don't want sine. So, of course, when you work out all of this, we would have gotten 0.4117. So when sine goes across, right, it becomes sine inverse. We did enough practice. We did sufficient practice on these questions for you all to be able to know how to do this right now, right? Because bearings will utilize your knowledge on the trig ratios and the sine rule, the cosine rule, etc., as you all can see it coming into play here. Okay? So again, when sine goes across, it becomes sine inverse of all of this, and all of this will have to be 0.4117. Okay, so theta would be 24.31. Up there, that just means we found theta. We just found this angle here, 24.31. To find the actual bearing, we would need to, where are all these lines coming out from? To find the actual bearing, we'll need to add that, we'll need to subtract that from 270 degrees. So 270 take away 24.31 and we get 245.7 degrees. All right, I feel like I was a little all over the place in this, but I hope you can just pull back the video and just take it in a little more if you're having problems with this type of question. Remember, the first one was easy to find, 90 degrees plus this angle, which is alternate to the angle given, 54. And we found JL by using the cosine rule, and we found this angle here, theta, by using the sine rule, and we took it away from 270 to find this bearing here. All right, and that's the three parts of the last three parts of the question. It goes for 7 marks. That's like the toughest part in trigs for you there for maths. So I hope that kind of shed some light on that for those who asked about this question, this exact same question. And you're able to walk through it by yourself. So go back and check another bearings question and see if you can do it. Remember, cosine rule, sine rule going to play a key factor most of the times in bearings questions. All right, till next time.
Okay, any questions so far?
No, sir.
Okay, so this next video, I'm not going to show it. It's an hour long, an hour and 15 minutes long, right? You all will, I will send it for you. I'll send a link for you, and you can go through it, and you will see how he is explaining it in great detail. All right? So this is the video here. If you want it, you can type in CSEC Maths Live -bearings and matrices, and you will get the video, right? Or I'll just send you the link right after class, okay? Yes, folks?
Yes, sir.
All right, so obviously I could not have explained all of this just by watching it and telling it to you all. That's why I showed you all the video, because he is actually going through it and he's actually demonstrating to you all. I cannot write on a PDF, and that's why I sometimes snip it and I put it on the paint, and I know I would not have been able to do a lot of the antics that he used with the video because I'm not too tech savvy, right? So yeah, that's why I showed you all the video. I apologize for teaching through a video, but that's all part of the learning process, right? Because I would have explained more or less along the same line. So that's why where his teaching methods differed from my teaching method, I paused the video and I explained why he did what he did, because I would explain everything in great detail. Obviously, he didn't explain every single thing in great detail. So that's why I paused the video in between and I explained what he was doing, etc. Right? So I hope nobody was confused and nobody wasn't struggling to follow. If you are, you can just let me know after class and I'll see how best I can try and help you, right? Well, that will be the end of class for today. So thankfully, we didn't have to go over the 12 o'clock. We finished on time. Of course, if I was teaching you all without the video, then it would have been over 12 o'clock, right? So any questions you all have for me before we end class? Do you all have any questions?
No, sir.
All right. Well, that will be the end. What's that?
Don't forget to send a note.
Oh yeah, just messages on the group chat now. So I will actually remember, because as soon as I finish here, I'm gonna eat, and then I usually forget everything that I tell you all. Right? So just message me now. Message on the group chat, say to send a note, and something else I had to send. I forget. You see? So yeah, just send it. Send a note, and the link. I'll have to send a link for you all. All right? So that's the end of class. Goodbye, everyone. See you all next
Bye,
week.
sir.
Bye.